Hello everyone, I'm Jochen Zimmer. I'm here from the company MakerBot, and we are also represented by our nice partners from 3D. You can find them outside. And I'm going to talk about 3D printing in education. This is going to be mostly MakerBot examples, of course, because this is what I'm working with, but I think many of the things I tell you are more generally applicable. So, first question that we sometimes ask ourselves, why should a company even care about education? Shouldn't we just, buy to the companies that can afford it? But, I mean, aside from the fact that, of course, many of us care personally about getting as many people as possible in contact with this nice, useful technology, of course, economically, this also makes sense, because for many technologies, it has been true that after a niche application, that just, a few people who can pay whatever the technology costs, it comes into educational use, and then later on the technology gets adopted more and more until it's a mass market. For 3D printing, actually, I know many people have heard about 3D printing quite recently, only maybe a few years ago. Maybe today is your first serious encounter with this, but companies have been 3D printing for prototyping for more than 20 years. The company Stratasys, that now also is that MakerBot also belongs to, has been producing 3D printers for more than 20 years, but most companies kept it secret because they didn't want the competition to know how they got all these nice products so quickly. So we're now looking to get an educational adoption for this technology on the way to mass market. And there's of course a cycle of impact here. So we're expecting if many people learn about this in school and university and know about the advantages of using a technology like this, then they will later come to the companies and help the adoption, and in the end help the whole economy make use of this, of the advantages of technology. And in these talks, we often try to draw a comparison between the adoption of PC technology, which kind of followed the same path. So in the beginning, people said, there's a market for maybe 3 computers, and a few companies had a mainframe and were using it, and this was pretty much it. And then in the 80s, people started to adopt these to the more innovative universities, and students started using them. And then nowadays, I mean, everybody has a computer in their pocket nowadays, so the adoption really takes a while, but then it really generates a lot of useful features for everybody. And we kind of see something similar. You see a picture here already. This is kind of a teaser. I'm going to talk later about how our technology is used in universities from this. So, how can you use actually 3D printing in education? Not just, everybody wants to somehow use it for this, but how is it actually useful? So, of course, the first thing is what I already said before. This is going to be adopted more and more. We're pushing for it, but it's going to happen anyway. And it's good to prepare the kids and the students of today already for this as the future of prototyping for sure, but also the future of manufacturing for many aspects, for small series, for individual products. So this is an excerpt from a German book that's designed for school children that explains how this technology works in principle. And those of you who know the 4th generation MakerBots can recognize this picture. But anyway, it explains in very general terms how FDM printing, which is what we are doing, works. But in principle, you could explain the additive process with any kind of 3D printing, and people would benefit from it and learn to think additively, which most engineers today really don't do, because they learn to think in casting or subtractive processes. Then you can use the 3D printer as a learning aid for totally different subjects. So this is an example here where the teacher can 3D print a model like a geometric, like a physical proof of the theorem of Pythagoras. So, of course, you have always a few kids who get it immediately and who just need to see the numbers, and you explain it to them and they say, oh, yes, sure. But you always have a few people who would benefit from you know, a more tangible kind of proof, and something you can really see and touch. And the beauty of this is, of course, if you say, and we only need a physical proof of Pythagoras and then all children will get mathematics, then you could also produce this in a more traditional way. But the 3D printer really gives the teacher the possibility to print exactly what he or she needs for this class, for these pupils. And you can have like a repository on the internet, and if only 3 classes in the world need one specific learning aid, one teacher makes the effort to create it, and the other 2 can just download it and profit from it and print it directly where they need it. And this really helps teachers that are trying to get involved and to help their students individually. This really gives them a very nice tool for this. And another great application in education is for individual projects. So, of course, you can teach the children to work with wood, or I don't know, in some cases with metal, or just with paper and stuff like that. But nowadays, it's probably a good idea, and the tools are available. Even cheap or free tools are available to really do 3-dimensional computer design of objects that you want to create. And it's very nice for the children to learn to do a 3D drawing and to create a product or create a robot, like in this case. So this is an example from, in Germany we have something called Jugend forscht. I don't know how this is spread throughout the rest of the world, but this is like young people have a research project and they work on it and then they present it to a jury. And this was from a regional champion who created a rescue robot with modular legs. So you could have the base robot was just from standard parts, and the legs you could print on a 3D printer depending on the environment. So he has legs for a swampy or sandy environment, legs for a hard environment, and so on. And you couldn't give every school child the possibility to make these in more old school production facilities. You wouldn't be able to give them the chance to mill it out of aluminum for all children, but 3D printing gives you the possibility to let every child 3D print what they created for projects like this. So I'm going quickly over the same thing. So these examples that I gave were mostly for school project, but the same, of course, just in more advanced level, is true for university projects. So, for example, teaching about the future of manufacturing, there's a very nice freely downloadable for every university educator, the Stratasys curriculum that really teaches about, in a broader scale and a 1 semester course, about the different ways of 3D printing prototypes and products. And to turn abstract mathematical concepts into actual experiences, of course, is not just true for something like Pythagoras, but for example, there is this math lecturer from the university, from the medicine university. Her pseudonym was Math Girl, and she uploaded dozens of designs that really can help you 3D visualize different concepts. For example, this is topology, knot theory, or here some basic 3-dimensional regular shapes, and lots of different examples that you can 3D print in a similar way. Of course, I mentioned this in the project solution, but you can use this to teach CAD in a more substantial way, really teach professional programs like this at university courses. And then if you have 3D printers available, every participant of the engineering course can actually print his final project, which was not possible before. And of course you can have, again, project work, like semester projects in this case. The example that I gave here we also have on our webpage, and it's about a group of students that made simulations, like finite element simulations of the aerodynamic properties of windmill blades, and then they optimized their design And then in order to really connect this to actual reality, they made a wind tunnel experiment, and for that they 3D printed the blades. And they could only have made them like this, or like I said, maybe in a milling way. So, we, from our company MakerBot, we offer several possibilities for the teachers to get into this. So it's not just enough to give them a printer, but actually you should provide some kind of content for the teacher to help them get into this, help them integrate it into existing curricula. And for the content, many of the examples, for example, this Pythagoras thing that I showed before is downloadable from the free and open repository Thingiverse, like the universe of things. And there's lots and lots of designs that are open source and can just be downloaded. How am I doing time-wise, by the way?
You're doing well.
Doing well, thanks. Okay, very good. And also we have produced something called MakerBot in the Classroom, which is a collection of lessons about CAD, about projects and so on, that students and teachers can use together to learn about this. And it covers stuff like the introduction to 3D printing. It helps people get started with it, and there are several projects in it for 3D printing, 3D design, and use cases from actual examples from the 3D printing world. And now I'm going to tell you quickly about some ways that we've thought about to actually help universities get into the 3D printing world. Something that we call a starter lab is a project solution that we offer where we give a full introductory course to the teachers how to use the technology, and provide a couple of different printers and installation services and so on. And now for the next couple of minutes, I'm going to tell you about the MakerBot Innovation Center. Actually, this is from the example that I gave in the very beginning. This is how we think adoption of the technology is going to happen, similar to the PC adoption in the 80s. So this is a solution that we've created to give the possibility to 3D print to a whole university. So everybody from the engineering faculty or everybody from the whole university can have access to 3D printing. And this works like this, that we have a farm of printers that are connected to a print server, and everybody can, through the internet, have access to the system, and it works like a printing service farm, so that everybody with access to the internet can connect to this innovation center and submit their 3D designs, and it can really work to give hundreds of people access to this kind of technology. And we've started implementing this a little more than a year ago in the US mainly, and we have 2 representatives here. I think you're going to, when are you up, guys? No, when is your talk? In a little while, these guys are going to present some of their work, which at least part of it, I think, took place on the first innovation center that we've installed in Europe, which is in Castellanza, close to Milan, but I think they might tell you a little more about this. And I'm going to skip through this. Yes, this is a picture I had prepared. This is their logo. It's the Lyon University, and this is a picture when you have 20 printers who have created beautiful designs after their first night of installation. So, with that, I'd like to finish. Thank you for the attention, and if there are any questions, it's open. Thanks.
I think it's obvious that this is a very important component of the education. How do they do it? So, for example, in Germany or in the US, is it organized by the state? Or is it individually by the universities and schools?
Unfortunately, it is not organized by the state. It's not in the US and in Germany. So far, these have been individual efforts of the local university and maybe groups that are involved with the university that are really wanting to go this extra step and to be the first and be the cutting edge in this case. So we have many of our customers are from the education field, but it's by no means mass adoption yet. So there are many universities.
Is that a kind of standardization? So if I go from one university to another, is it the same lab for these practices and all these applications?
Not
okay, I really understand that each and maybe 1,000 models and all these shapes. It's just beautiful. But it seems that the state is not financing.
No, not yet. So this is mainly an effort from our side to get this adopted, and then some people who get it and who try to implement it themselves.
Okay, thank you. Do we have any question? No questions? All the questions.